So this lesson is going to serve as an opportunity for us to review the concept of density and use it as a conversion factor, and then also to look at some slightly more complicated conversion practice problems. Okay? So density is probably a concept you have already studied in class, in a science class. Density allows us to relate mass and volume to one another. And the reason why density is so useful is it actually enables us to identify substances, because every substance that exists on Earth has a unique density. So the density of gold is different from the density of silver, which is different from the density of iron. So it actually allows us to identify substances if we can first determine their densities. So just as a quick review, the mathematical equation for density is mass divided by volume. Okay, so it's the amount of mass in a specific volume. Now the units for density, they can be varied, but typically what you'll see, the units for mass are grams, the units for volume, typically, most common, are milliliters. So the units for density, you'll often see grams per mil. You might also see grams per liter. You might also see kilograms per liter. Then there is one other kind of quirky unit that you'll see, okay? And that is centimeters cubed. So it's important for you to know that 1 milliliter equals 1 cubic centimeter. So what that tells us is if you make a cube, okay, and each of its sides had a length of 1 centimeter, its volume would be 1 times 1 times 1, because volume of a cube is length times width times height. That would be, its volume would be 1 centimeter cubed, and its volume would also be 1 milliliter. So 1 cubic centimeter is the same thing as 1 milliliter. Okay? So sometimes we'll actually use this equation, density equals mass over volume. I tend to only like to use it when I'm actually solving for density itself. Otherwise, if I'm given density and asked for one of these variables, for mass or for volume, I actually like to use density as a conversion factor. And I'm going to show you in a number of problems just how I do that. Okay, so let's look at the first example. It says, what is the density of a piece of metal if the mass, so I'm solving for density, so I'm going to use my formula. Okay, it tells me my mass is 562 grams. Okay. And it tells me my volume is 14 milliliters. So I'm first going to put my unrounded value here. So my unrounded value that I get is 40 point, I'm going to actually round a little bit, so don't go too crazy. 3. My units are grams per mil, because I divided mass, grams, by milliliters. Okay. Now I need to figure out significant figures. So since I'm dividing, I'm going to be rounding to my fewest number of Sig Figs. 562 has 3 Sig Figs, 14 has 2, which means I want my final answer to have 2 Sig Figs. So I want to keep the 4 and the 0. The 1 does not round the 0 up, so I'm going to end up with 40. Now here's the problem. I want 2 Sig Figs, but if I just write 40, then that would be 1 significant figure. So what I'm actually going to need to do is put a decimal place so that now I can count from left to right so that the 4 and the 0 are significant. And my units are grams per mil. Okay? And that's my answer. Okay? Let's look at the next practice problem. An object has a mass of 3.15 ounces when it is submerged in a graduated cylinder initially containing 325 mils of water. The water level rises to 442.5 mils. What is its density? So there are two different issues I have. The first, the mass I'm given is in ounces. And notice, based on the units for density, I want to get into grams. So I'm going to use the conversion factors I gave you here to figure out the mass. So I'm going to do that in 1 second. I also need to discuss the fact that it tells me I've got a graduated cylinder. It initially has a volume of 325.2 mils of water. Well, why does that matter? Well, they're not directly telling me what the volume of my object is. Instead, what it's saying is, hey, if I take this object and I drop it into water, then that will cause the water level to rise to 442.5. So without the object, it was 325.2. Now it's 442.5. So what I can do is if I take the difference between those two volumes, right, that'll tell me the actual volume of the object. 325.2 is the volume of just water. It rose to 442.5 as soon as you added the object. So logic tells you that that must be the volume of the object itself. And so the volume of the object itself is going to be 117.3, if I subtract, moles. So now I've got my volume, so I'm good there. Now I've got to figure out my mass. Okay, I'm in ounces. I want to get into grams because that's the unit for density that I want for mass. So notice the two conversion factors allows me to get out of ounces, first into pounds. Okay, now I'm in pounds. I don't want to stay in pounds. Now I can get into grams. Okay, so in one pound has 16 ounces. 1 pound has 454 grams. So I'm going to take 3.15, divide by 16, and then multiply by 454. And what I end up getting is 89.38125. Now notice I'm not rounding this value. When you're dealing with a multi-step problem like this one, where you're having to multiply, subtract everything, do not round until the very end, okay? And then I will round, okay? So now I can actually calculate my density. I know my mass is 89.38125, okay? My volume is 117.3 mils. And so unrounded, this value is 0.761988. Okay, let's figure out Sig Figs. So this is where it gets a little bit complicated, so you got to really pay attention with Sig Figs. For my mass, remember the conversion factors don't count towards Sig Figs, so I'm just looking at 315. So that has 3 Sig Figs. Because remember, the last thing I'm doing is dividing, so I need to round based on the fewest number of Sig Figs. So my answer up top should have 3 Sig Figs. I didn't round it to 3 Sig Figs because I didn't want to over-round it. Then, to find my volume, I subtracted. Remember, the rule for subtraction is you use the fewest number of decimal places. Okay? Well, 442.5 and 325.2 both have 1 decimal place, so this is actually how it should have been rounded. So this number should have, and does have, a total of 4 significant figures. Okay. Do you see how that's complicated? You're actually subtracting here. You have to keep it in here, right, for your volume. You have to keep in mind what the number of Sig Figs should be, but not round it until the very end. So that keeping track, I know we'll struggle with it a little bit, but I'll make sure to ask questions if it doesn't make sense to you. So I need to round my final answer to 3 Sig Figs. So what I get is 0.762, and my units are grams per mil. Okay. All right. So in this problem, it says if the density of a substance is 0.56 grams per mil, what is the volume if the mass is 3.5 grams? So remember, I'm going to use density as a conversion factor. So I'm going to start with my given, which is 3.5 grams. And it wants me to get into milliliters because those are my units for volume. So what I'm going to do is I'm going to put grams on bottom to cancel them out, and I'm going to put milliliters up top. Okay? Now, based on this relationship given by density, what this is telling me is there are 0.56 grams in every 1 milliliter. So I can easily plug that in now. 1 mil is 0.56 grams. Okay, so now I want to figure out my answer. So I'm going to take 3.5 and I'm going to divide by 0.56. And what I get is 6.25. Okay, and my units are mils. Now I've got to figure out my Sig Figs. So 3.5 has 2 Sig Figs. Okay. This density here, 0.56, has 2 Sig Figs as well, which means that my final answer needs 2 Sig Figs. Okay, so I'm going to round this, and it's going to become 6.3 milliliters. All right, for the next question, it says if the density of liquid mercury is 13.6 grams per mil, what is the mass of 35 mils of a sample of mercury? Now, traditionally, you can, and it's not wrong, you can use the formula density equals mass over volume. I find that students make a number of careless errors when they do that. Instead, what I recommend doing is actually using density as a conversion factor. So let me show you what that looks like. Just like any other conversion problem we've done, we've got to start with our given. So we're told our volume is 35 mils. Okay? And I want to get into kilograms. Okay? But to do that, I first need to get out of mils, so I'm going to put it on bottom. And what I'm going to get into first is actually grams. Okay? I'm going to do another step because I don't want to stay in grams. I want to get into kilograms, so grams is going to go on bottom, kilograms is going to go on top. All right, let's actually plug in our values now. I actually know this relationship, grams per mil, because looking at my density, this tells me I have 13.6 grams for every 1 milliliter. Okay? For here, kilograms to grams, 1 kilogram is 10 to the third grams. So now all I have to do is the math, 35 times 13.6 divided by 1,000, and what I get unrounded is 0.476 kilograms. Okay, this and this are both conversion factors, so I'm just going to use 35 for Sig Figs. So I should have only 2 Sig Figs. 1, 2. The 6 rounds the 7 up, so this is going to be 0.48 kilograms. Okay, let's look at one last practice problem. What volume in milliliters will 45.0 grams of an unknown gas occupy if the density of the gas is 2.26 grams per liter? So again, I'm going to start with my given, 45.0 grams. I want to get into milliliters. So first, I'm going to get out of grams. I'm going to get into liters first because I know that relationship based on my density. Okay? I don't want to stay in liters though. I want to get into milliliters. So I'm going to do that. Okay. Now I'm going to plug in my values. I know I have 2.26 grams for every 1 liter, and I know that 1 milliliter is 10 to the negative third liters. Obviously for these prefix ones, guys, I would give you those values. Okay. So for this problem, my answer, I'm going to 45 divided by 2.26 divided by 10 to the negative third, I get the following answer, unrounded. Okay, I know, again, I ignore these because these are exact relationships. I have 1, 2, 3 Sig Figs. 1, 2, 3 Sig Figs. So I have 199. The 1 does not round the 9 up, and I need to hold those places. Please don't forget those zeros. You don't want to change 19,000 to 199. Okay? And my units, I ended up in milliliters.